Hello everyone and welcome back to another video. This video this time it's gonna be I'm gonna do something similar to like deleting and value, but unlike the other video, this one is more about how to delete basically the first node and the last node. Okay, so let's start off with how to delete the first node. We're gonna have public void delete first. We're gonna call it delete first. Okay, and all it does is we're gonna have a base case, right? Which is if head is equal to null, then we just need to return it. That means the list is already empty. If list is empty, and it will just do nothing basically, right? But if not, then all we need to do is put head equals head.next. The reason we do that is, let's put, for example, we have head at 1, and it goes to no, it goes to the next one, which is 2, goes to 3, something like that, and then goes to null. If we want to remove basically just the first one, then we just need to put the head, we just need to change the head to equal to head.next, and head.next would be 2, so it will look like this instead. And when that happens, the head is gone and there's no connection between the 1 and the head, right? So that 1 would still be there, but there's no way to get to the 1. So it kind of just sort of like disappears, or basically not being there at all. So that's how you do delete first, and I'll show you like the example later. Here's with the second one, how to delete like the last node. So we're gonna call it public void delete last. And to do that, again, we will have a base case, which is if head equals null, then return. Again, it's the same thing. It just shows if list is empty, there's nothing to do. Next, we make a if statement, calling it if head next equals null, then head equals null, and then return. The reason why we got to do this is this is to make sure if only one node exists, right? Is that how I spell it? No, that's not how you spell it. There we go. If one node exists. And let me just continue real quick before explaining it in case. Now we'll create a node temp equals head, and while temp.next is not equal to null, temp equals temp.next, and then temp.next equals null. Now the reason we gotta do this is so if we were to first, let's do something like this. Let's make a head equals 1, and then head is 1, and then it goes to null right afterward, right? So if we want to delete the last node, which if like head.next, which right here, head's next is equal to null, then head just equals to null, and then you return. That means when that happens, you put the head over here like that, and then the head disappears. That just basically makes the one like disappear pretty much, which is that one single node, and that tells you like, since it's only one node, that is the last node to basically delete. But if we were to say with like so this is also like it's like a case number 2, right? If only one node exists, you remove that one node. But with this right here, this thing is basically how you have to like go down the list, sort of. So I'll write it out first. So head goes to 1, goes to 2, goes to 3, and then goes to null. So we're gonna have a null that is called temp, and that's equal to head, which is 1. So while the temp next is not equal to null. So 1's next, which is 3, and 3 is not equal to null. That means you move the temp to 2 because temp dot next right here, right? And then afterward, you look at it again, is temp next. Oh, sorry, temp, which is equal to 2, next, is it not equal to null? This is false. So the while statement is false because it is equal to null. And since this is false now, the while loop ends. And then that just means that temp.next will be equal to null. So that means that this 2, the next one, should be null instead. And when that happens, this 3 that is still pointing null is kind of disconnected because the 2 can't connect to the 3 anymore. Since 2, which is temp.next, is now equal to null, it no longer points at 3. So the 3 just sort of like goes away. But I mean, it's still there, but you gotta imagine it's kind of like not there, you know? So that's how you sort of like delete the very last node while keeping every other node like still there. Okay, now that I think I've explained it, let's do the examples. And keep in mind, delete first is the time complexity is 001 because you're deleting the very first one. So it just takes one unit of time. Delete last node is always going to be O of n because you have to go through the whole list, the whole linked list. So from beginning all the way to the end in order to delete the last one. So that's why it's O of n for time complexity for delete last. And we're gonna quickly do this. So list dot, we already have 10, 20, 30. List delete first. So this should print out 20 and 30 only. Yep, 20 and 30, right? And oops. And then if we were to do list delete last, they should only print out 10 and 20. Yep, 10 and 20. And that's how you do it. Yeah, and that's pretty much it. Thanks for watching.